Okay, and welcome back to episode 7 of Trying to Draw a Triangle. It's been about a week since I last got back to this project, so I'm going to have to take a minute to kind of reorient myself. It's just been a busy week, so I've not really had the time to do much. One thing I have had a bit of a chance to do is I've been playing with Cocoon instead of Neovim, so I'm umming about trying to do a bit of programming on the stream in Cocoon to see how we go. So if things are a bit janky and slow, you know why. And if it's just a nightmare, we'll bail and go back to Neovim. But I don't know. I've enjoyed kind of the Cocoon mindset. I like the very simple idea for how to build things. So let's give it a shake and see if it's actually any good. Right. So where actually are we? Back to the Flectris. We'll make a new team-up session to work in. And we are partway through setting up our graphics library. Not graphics library, sorry, graphics pipeline. We are absolutely going to need the spec. I can't remember why I was on shader modules, because I think we're past that. Is there a fit to width? There we go. So we're going to need the docs. We are going to want to start out probably in main renderer. And let's see if we can find where we were up to. So, yeah, this is what we were doing last time. We're setting up our graphics pipeline create info. So we can create a graphics pipeline with some sensible things in it. And fortunately, past me was sensible enough to leave a little note. So we're on to the layout in part 14.2.2. I guess we just dive straight in. 14. Yeah, okay, so descriptor sets. This is one of those parts of the Vulkan spec that I remember being very fuzzy on, so this may be painful. Just to remind myself where we're up to. So we're making the graphics pipeline, which, if I have understood it correctly, is basically we're just setting up all of the various sort of objects that our graphics card needs in order to sensibly submit draw calls, essentially. So, as part of that, what do we have? Oh, I can't remember. What's pipeline stages? So we have pipeline shader stages, which includes a vertex and a fragment shader. We've got a very simple pipeline that those are the only two steps we're actually going to custom, or where we're going to run our custom shaders in. They make use of shader modules, which have access to our compiled shader code. Vertex input state create info, and then input assembly create info. So the input assembly create info says how we're going to consume our list of vertices and specifies we're going to have them as a list of triangles. The vertex input state create info takes our binding description and our input attribute descriptions. Just check if my LSP is set up, and it is. Nice. And those say, what do they say? Basically what our vertex data looks like and how to pull values off of it. So that's those two. We set our viewport and scissor, which say what part of the surface we would like to draw to. So used for culling sensibly. Our rasterization state, where we set our backface culling, which is a performance optimization. We define which way our triangles wind. So we define which side of the triangle is the front and the back. We are turning off multi-sampling because we're not doing any anti-aliasing. I don't know how to scroll that to the middle in Cocoon, so we're just going to do it dumbly. And so all that's left now is our layout and render pass, where layout is about... What is layout about? I think a layout is about defining what descriptor sets are going to be made available. I'm not actually certain we're going to need any descriptor sets. Did I put any of these on graphics pipeline create? I did not. So, can we find our create graphics pipeline thing up here where we have VK pipeline layout and just see what it says it is. Layout is the description of binding locations used by both the pipeline and descriptor sets used with the pipeline. If API version is greater than or equal to 1.3, and this thing is enabled, layout must not be accessed outside of the duration of the command this structure is passed to. Okay. That doesn't tell us a whole lot, really. So if we come back to, what's my note say, 14.2.2, I think we might not actually need any descriptors currently, because all we've got is, at the minute, a vertex buffer. And our vertex buffer, or our vertices, include their color data on them. So it's not like we have any, we're not sampling any texture images or anything. And descriptor types are storage images, samplers and sampled images, texel buffers, which I think are just flat buffers with extra information about the format of the data in them, a storage buffer, or a uniform buffer, an input attachment is a descriptor type associated with an image resource via an image view that can be used for frame buffer local load operations in fragment shaders. Which I think means it's for reading from them. Which again, I don't think we need, so I think we might be able to just skim past that. Using input attachment must be on one of these layouts. So, storage tensor resource which we're not using, and then we have descriptor sets. Descriptors are grouped together, so descriptors being those resources that we've just seen, get grouped together into descriptor set objects. A descriptor set object is an opaque object containing storage for a set of descriptors where the types and numbers of descriptors is defined by descriptor set layout. The layout object may be used to define the association of each descriptor binding with memory or other implementation resources. The layout is used both for determining the resources that need to be associated with the descriptor set and determining the interface between shader set stages and shader resources. A descriptor set layout object is defined by an array of 0 or more descriptor bindings. So, we are allowed to pass in 0. Each individual descriptor binding is specified by a descriptor type, a count, array size, and the number of descriptors in the binding, a set of shader stages that can access the binding, and if using immutable samplers, an array of sampler descriptors. Descriptor set layout objects are represented by descriptor set layout handles. To create them, we call this thing which has a create info and allocator. It can fail, so I guess let's put this in here. So let's say descriptor set layout will be a VK descriptor set layout layout create res will be VK create descriptor set layout for renderer dot device descriptor set layout create info. That will need to be a pointer to that. We don't have an allocator, and we want to set it into there. Oops. So that doesn't exist yet. I want to say in here, so if layout create res is a failure, is not equal to success, then we will panic with failed to create. What do we do? Descriptor set layout. We need to make this thing though, so descriptor set layout create info. So VK, I'm gonna guess descriptor set layout create info. Yep, descriptor set layout create info. And hopefully we skim down here and we can find it just there. We have our ever annoying S-type field to fill in, which is descriptor set layout create info. Pnex we hopefully don't need. Flags is a bit mask specifying options for its creation, so I'll put an empty flags as a reminder. Then binding count and pointer to bindings. I'm hoping we can get away with 0. But again, I'll just leave these in here. It's a bit of a reminder. Oh, did I just make a file I didn't mean to? No, okay, good. So, where does that leave us then? Let me format that, because I've got my thing generating tabs in the wrong size, but never mind. So we do all of that, and then down here we've now got our empty layout that we can pass into here, right? So this will now be a pointer to descriptor set layout. No. Why not? Can I see your type? You're a pipeline layout. Oh. It's a pipeline layout, not descriptor set layout. What is the difference? Damn it, past Matt. Giving me bad advice. Okay, let's go have a look again. Yeah, there you go, it's a pipeline layout. What is a pipeline layout then? It does not seem to say. Pipeline vertex input state. Bunch of stuff about render pass, bunch of stuff about dynamic state. Huge chunk of correct usage that we hopefully don't need to read because the validation layers should catch it all for us. If we are lucky. My god, there's a lot of it. Pipeline rendering create info is the thing that we're going to end up needing for the new dynamic rendering stuff, I think. But that means we're not there yet. Ugh, that's annoying. How would I find... Let me search for SVK pipeline. Pipeline layout. Within the VK pipeline layout, you have all this stuff. To create a pipeline layout, you call this. So over here we have descriptor set layout. Here we have pipeline layouts. They are not the same. Okay. Shall we delete that then? So we don't need this. And you are now wrong, so we're going to have a pipeline layout instead. Okay, let's try again. So pipeline layout will be a VK pipeline layout. Pipeline, Christ, if only I could type pipeline layout. Create info is a thing we're going to have to fill in. Yeah, there is one on there. So pipeline layout create info. Which we will do in a bit. So let's stick a to do on there. And then we'll have pipeline layout create res will be equal to create pipeline layout for renderer dot device pipeline layout create info. We have no custom allocator, and we would like to store the result in our pipeline layout variable. And then, as always, if that res is not equal to success, then panic. Okay, now we've got the right type. Failed to create pipe line layout. There we go. That's still not happy. Is it not a pointer? Is that the issue? Yes. Okay. Can we find our pipeline layout create info? Which takes a script set layout count and a push constant range. So I think we get away with neither. So I think we can just make a empty one of these that has the right S type on it. So what actually are you? You're a pipeline layout create info. P next we ignore. I will put empty flags to remind myself they exist, and then we're going to have ourselves set layout count is 0, P set layout is nil, push constant range count is 0, and we have no what's it called? No list of them either. We probably should have tried running this before I got this far. Okay, so it compiles, and its only complaint is it has no render pass. So that looks at least like it's going in the right direction. I am going to take a short break, so I'll be back in 1 minute. Okay, sorry about that. Where were we? Yes, we've made our empty pipeline layout, which does nothing, but it looks like it needs to just exist. Which means we've got one last thing to go and look at, which, if I'm honest, I've been putting off a little bit because I think render pass is where this change to how rendering works will now affect us. Wait, am I looking in the wrong place? Graphics pipelines. So let's have a quick look into here. Do you have a nice link for how to find render passes? Render pass is a handle to a render pass object describing the environment in which the pipeline will be used. It must only be used with a render pass instance compatible with the one provided. So in a word, no, not really. Does any of this say anything about render passes? Under resource creation, maybe? Under descriptors, shader interfaces. There must be a section on render passes. Oh, okay, it's for earlier on. That's interesting. Is there anything useful in this first chunk then? It's just it's saying the whole stuff about they've changed from the old original way of doing it to this dynamic way of doing it. Rendering attachment info. Get past all of this detail. There we go. So render pass. Draw commands must be recorded within a render pass instance. Each render pass instance defines a set of image resources referred to as attachments used during rendering. Then here's our commands to begin them and end them. Is there a render pass create? Rendering info. There must be something in here about render pass create, mustn't there? Rendering flag. Rendering flags. Rendering attachment info. Rendering area info from 1.4. Sorry, I'm going to sneeze. Apologies. I'm sure that sounded disgusting. There we go. A render pass object represents a collection of attachment subpasses and dependencies between the subpasses. Oh, this whole thing is deprecated. So what do I pass into my graphics pipeline now then? So render pass creation is deprecated. See deprecated functionality, which we've seen before. So in Vulkan 1.3, dynamic rendering extension was promoted into core. Added a new way to specify render passes without needing to create these objects. However, subpass functionality, blah blah blah, local read, blah blah blah, and then there's some examples for how you do it. Sorry. And there's some cases where you still need it. Ugh, okay. But I don't understand, because the thing over here is still complaining. Ah, okay. Dynamic rendering feature was not enabled. I need to go and enable dynamic rendering. So the Vulkan spec states, if the dynamic rendering feature is not enabled and the pipeline requires pre-rasterization shader state, fragment shader state, or fragment output interface state, render pass must not be null. Where do I enable dynamic rendering? Is that something I was meant to have done on my pipeline? Can I look for rendering? Split frame rendering. Maybe dynamic rendering. Where actually are we now then? When using dynamic rendering with local read feature enabled, how do I just enable it though? I mean, this must be the right kind of area, mustn't it? Clearing image inside of a render pass. Yeah, but where do I enable the feature? Oh, sorry, I'm gonna have to go again. And I am back again. Sorry for the interruptions. I should have done this before I got so old and had so many other responsibilities. Yes, how do we enable this feature? Does this link just tell us exactly what to do? Because that would be convenient. Let's see. Is this going to be an enormous page? It's going to be really slow. As here, Vulkan enable dynamic rendering. Something you have to enable on the device, is it? Sample demonstrates how to use VKKHR dynamic render extension. Previously, when you do all of this, change how pipelines are created. So this ends up being null. There we go. Enable the extension. So in addition, since dynamic rendering is provided as an extension and may have varying levels of support, the developer must query availability for each device used. The device extension is provided by this extension name, and additional features are provided by this struct. In addition to enabling the extension, developers may need to dynamically query the function pointers for these things. Okay. What is this? Okay. That is less helpful than I thought it was going to be. Does that just link to the same thing that I was just reading? Another thing, the Vulkan docs are very thorough, but they're not very, like, person-friendly. So what is this saying? They get device, they get the GPU, they get the instance, they get a handle, they set that to instance, they assert the instance exists. Get instance proc adder. So they get the functions, and then they blow up if they don't exist. Okay, so that doesn't help us particularly. Is it a... So it's a device extension. We've got device extensions already. There. So when we create our device, we're already passing in some extensions. I'll tell you what, I might do a quick commit just in case we put this in the wrong place. So work in progress, empty, pipeline, layout. Oops, this is where using a different editor's messing with me. So how do I go to the end? I have to do G and then move to the right. Do you have this already saved? You do, which is nice. And just out of interest, if I jump to you, you are called VKKHR Dynamic Rendering. And if we jump to you, that's what you were called, VKKHR Dynamic Rendering. Nice. Which then means that if we go back down to our... What is it called? It's where we're setting our render pass up, isn't it? Okay, so it's not there. GLFW's doing a load of stuff. Sorry, I'm in the wrong place, aren't I? I need to go back to my renderer. Then down here, we could just leave that actually, but I want to set it explicitly because I now remember that that's a real thing that I mean to do. And hopefully, if we come into here, we get rid of that file that I've made accidentally. And let's just sanity check. So I have added it there. I now go Odin run main. Cannot convert untyped value nil to a render pass. Can I do that instead? Because I think that works for everything. No. Because the dynamic rendering feature was not enabled. Okay. Pipeline requires this. Is this something that goes on the pipeline then? Is this going to be one of these flags? Let's go have a check in here. So you have a bunch of stuff. Is one of these going to say dynamic rendering? In fact, let's jump up here and do a search for, I guess, dynamic. Pipeline dynamic state creating. Ah, did it go on that? Physical device dynamic rendering features. That also sounds like it could be it, doesn't it? Then there's the extension, vertex input dynamic state. Okay, we might have to go and have a read about these flags then. What were we just in then? Guess we're back in here. Okay, so at least we know our device does support the extension. So let's go back to this graphics pipeline bit. Where am I looking? Number 10, graphics pipeline. Let's go look at the create flags. Flags. Flags is loads of these things. And just on here, can I do a search for dynamic rendering? What's it say? Rendering fragment density, fragment shading rate, divided by this thing. Image layout shading. Okay. Is it because I didn't put it in capitals? I kind of expect to see just a thing that said. I thought I did see one actually when I was looking in here. Is there not one of these that just says dynamic rendering? Pipeline dynamic state create info. Is that where I need to go and look? We jump back to our pipeline. Create wherever that was. Add it there. We have dynamic state. Do you have something in you about dynamic rendering? Dynamic state. Press P dynamic states. Viewport, scissor, line width, depth bias, blend constants, depth bounds, stencil, cull mode, front face, primitive topology, viewport with count, scissor with count, vertex input binding stride, depth test, depth, stencil, rasterizer, depth primitive, line, viewport, discard, sample locations, ray tracing, some viewport thing, vertex input. I mean, none of these look like it, do they? There's a good chunk left, though. Dynamic state. Okay, let's scroll back up. And let's do a search in here for, I guess just for rendering. Yeah, so that just skimmed over all of them, didn't it? Oh, how do I enable that feature then? Do a search in here for dynamic, what we call dynamic state create flags. That is where you're defined. You're a bit set for these things. No, I think I'm just getting nowhere, aren't I? Head back to our renderer. So it's that dynamic rendering. Message ID is this stuff. But the dynamic rendering feature was not enabled. So Vulkan enable dynamic rendering feature as opposed to extension. You need to add this extension and enable the dynamic rendering feature within the Vulkan 1.3 core or via the extension on older versions. Do we trust the AI? Hey, enable the feature. You must query for device support and enable it, but we're targeting 1.3 or greater, so it doesn't matter. Create a VK physical device dynamic rendering features KHR struct. And you pass it. Ah. Okay, so you can't just have it in your extension list, you also need to make this thing. Cool. Let's do a search in here then. Hopefully it isn't too slow. Nice. So let's just jump to you. Where is it? Formats. There we go. There we go. Structure defined as this. Okay. So we're back in here. Let's go find, I guess, the point where we make our renderer.device for the first time. So if we go to the top and find the first place that does it, we're in Nya. We make our create info, which I guess must have a p next on it, which I will point that to our physical. Oh, it's on physical device. What? Defined as this. Is included in the pnext chain of physical device features struct pass to get physical device features. It is filled in to indicate whether each feature is supported. If the application wishes to use a VK device with any features described by this, it must add an instance of the structure to its VK device create info. Yeah, okay, that's what we're doing here. So we're just going to assume it's supported because we're on Vulkan 1.3. And then this can have on it a dynamic rendering feature. Dynamic rendering features. Rendering features. We'll come up here and we'll say that dynamic rendering features will be physical device dynamic rendering features. S-type is physical device. No, can't type. And can't remember that Cocoon does its motions backwards. So it's physical device dynamic rendering features. Your pnext is nil, and it's just a bool. So we have dynamic rendering is true. We will format, we will run, and we have no more complaints. Okay, that feels worth a commit. So what do you have to say there? Graphics pipeline made no validation errors. Now, sadly, that doesn't necessarily mean that it all works. It just means that we're not technically calling anything in the API incorrectly. But that's progress of a sort, I guess. Just got to keep an eye on the time. It sounds like I think I'm going to be cut off short again. Problems with being a grown-up, isn't it? So maybe the best thing to do now would be to have a bit of a read and get my head around this dynamic rendering stuff. So this is what I've done every other time I've done any graphics work at all. To begin your rendering with a begin render pass. That object no longer exists, so we're now using this. And it does look like there's just kind of a one-for-one replacement, where instead of making this frame buffer ahead of time, I guess you do these things. Frame buffer objects are heap allocated and opaque, whereas these are stack allocated. Okay. Do you know, I think this is just not going to make any sense to me until we actually do it. So, we will worry more about that when we have to. One thing I think we can do quite quickly, though, we can jump back here. So I quite like this bloke's diagram for trying to keep track of where we're up to. Bearing in mind, this is no longer the way this works, so it's all kind of the same up until we're down here. But he shows we make an instance and a surface, we get our physical device, we get our logical device, we grab our queue. We've made our buffers to put our data into. We currently have our swap chain images, but we don't have any of these image views or samplers to care about yet. That's not true. We have image views for the swap chain images that we might need to do some like layout changes on. But the main meat that we've just done is basically this stuff down here. We have no descriptor sets, so we can ignore some of this stuff, but we've now got a pipeline. So we're down to here. We currently have no synchronization or command submission ability. So I think our next stop is probably to go and add a command pool up here, so that we can start making command buffers, so that we can start submitting draw calls, and then we'll finally see if our thing works. So, command buffers. I don't know if we need to read all of this. Command pools, we will need to read. So, command pools are opaque objects that command buffer memory is allocated from. Let's do a quick just check there. So if we just hop down a little bit, I think we are going to need a single command pool that we will keep like so on our renderer. And as part of initializing, we will have to create a command pool. So we make our logical device, we make our swap chain, make swap chain images, make the image views. I might squeeze it in here. So create command pool. Only because I think there are future versions of this where we might end up wanting to do like staging buffers and things, in which case, you know, we'll end up making transfer commands to move stuff around between these different like buffers. We're not doing it currently. I'm actually not sure we're ever going to need to, but it feels like a logical place to put it. So, how do we make a command pool? It returns a VK result. It could fail. So we're going to have a res is equal to VK create command pool, which will take some stuff. One of the things it will have to take is a pointer to command pool, which already exists on our renderer, so we don't need to make space for it. We will need to create info though. So let's come back in here and we'll make a, what's it called? VK command pool create info struct, which we will need to fill in. Okay. And our create command pool takes our device, because of course it does. It takes a pointer to our create info. We do not have a custom allocator, and it will put the created command pool handle on our renderer directly, like so. If res is not success, panic, sorry. Like I say, I think I'm trying to get used to using Cocoon instead of Vim. So what do you have to do? You have to do Alt-I to select inside. Didn't work. Why did that not work? Let's go back. Did not Alt-I. There you go. Alt-I, quotes to select inside. Grab that. Failed to create command pool. Nice. Our create info is wrong though. You will definitely have an S type on you because everything in the world does. This will have to say command pool create info. And then let's skim the docs to see what the other interesting fields are. P next, flags, and a Q family index. So, flags, I'm going to make empty for now. I think we are going to have to set a flag though, if I remember right. Our Q family index, I think we might have saved the one we're going to use. So, we're doing the absolute simplest thing possible. When we initialized and we grabbed our device, we grabbed our Q handle, we've grabbed a Q family index that is capable of all of the types of commands we're going to want to do, including, I think, transfers, which we don't do any of yet, but we might want to do. So we grabbed the one Q family index and we use it for everything. I guess what this says is if you had multiple Q family indices, we'd need to make multiple command pools and we'd have to worry about it. But like I said, that was kind of the reason why we kept this simple when we were setting that up. And then we have this, which we are going to want to think about a little bit. So, how are we going to make our commands? So transient, if I remember right, I think basically says I'm only going to make very short-lived command buffers. Transient bit specifies command buffers allocated from the pool will be short-lived, meaning they will be reset or freed in a relatively short time frame, which may be used to control memory allocation behavior within the pool. So yeah, we're giving a hint to our driver so it can make better use of memory. What is this? The reset command buffer bit allows any command buffer allocated from a pool to be individually reset to the initial state, either by calling reset command buffer or via the implicit reset when calling VK begin command buffer. If this flag is not set on a pool, then reset command buffer must not be called for any command buffer allocated from the pool. And then protected specifies that the ones that are allocated from the pool are protected command buffers, which I think is a safety feature that we have not used anywhere, so we're not fussed. So the question is, are we going to set this reset thing? I think this relates to this life cycle up here. So if you have reset, then what you allow is a command buffer that you're going to call once, and then you're going to create and call a very similar one again, instead of having to allocate a new initial command buffer, come round, execute it, and then if you have a one-time submit, it becomes invalid. Instead of then having to reallocate a similar bunch of memory, when you begin your next command, it can, I guess the driver can decide whether or not it'd be more efficient to reset that command buffer and take it back around again and avoid this. I don't see any pain in doing that. I don't actually know. Are we going to be I guess we're going to be recording a command each draw frame. Although what we're going to do is basically the same every frame, so we might be able to pull that out and do it ahead of time. I don't know. I'm going to set this flag. So I think one thing it does say is it allows this reset to happen quietly and in the background. I don't think it precludes you from doing anything. I guess there probably is a cost if you do it and you absolutely don't need to. But let's pop that in there. My God, I'm struggling with this cocoon still. There we go. Tidy it up. So we create a command pool, check it's created successfully. I don't know if we're going to get a validation error because we're not tearing it down. So let's go and see. So we do that. So we aren't getting one. I imagine because we're not actually allocating any memory off of it yet. I'm just going to have a quick look and see if there is a destroy call. Because, like I keep saying, I think if we do this in a way that's very neat, it will make it easier for us later if we want to do something where like there's a settings button on the main menu where you can like change what GPU you're pointing at or something. We could just tear everything down, set it all back up again. Ooh, what does reset do? Resets command pool, recycled all the resources from all the command buffers allocated. All command buffers that have been allocated are put into the initial state. Anything that's midway gets made invalid. Interesting. I don't know, we're going to need that. There we go. We can destroy the command pool. So let's jump down here. We have our dinit thing. I don't actually know that it matters where we put this. So I'm just going to stick it at the top. So VK destroy command pool. This is another one of those where I don't think it makes too much sense to worry about, because if we put it in the wrong place, then we should get corrected. Yeah, it just takes the command pool and allocator. We should get corrected by what's it called? My God, why can't I think of the word? We'll get corrected by the validation layers if we put this in the wrong place. And nil, because again, we don't have any custom command memory allocator. Come back, run this, tear down, no failures. Happy days. So git add all, git commit, and we now have correct command pool. Nice. Now, do we need to make our synchronization stuff ahead of time, or do we do it at the end? I think we might add the synchronization primitives as we need them, because I don't know this stuff well enough to know before we start actually what I'll need. So I'm hoping actually there's a really nice chunk about that in here. Yeah, so you can see the nice structured layout here. So it's fences and semaphores we're going to need. If I remember right, I think fences are about fences will be useful for synchronizing across the GPU and CPU. So in the first thing we write, I guess we will have the CPU submit a draw call, and then the CPU will wait to know that the GPU is finished, and then we'll submit another draw call for the next frame. I think we do that using a fence. And then semaphores will be used for synchronizing within our draw call. So if one step of the graphics pipeline needs to wait for another step to do something, I think you do that all with semaphores, which kind of like pass a signal on once the thing is done, and then other things can listen to it and pick up when they should do. But like I said, I don't know that well enough to just do it. Which I guess means we're on to thinking about how we actually do a draw. Does that mean we're going to have to make a separate function? Because so far, everything we've done, all of this in here, do you know, I should really check if there's a jump to matching bracket, because the way I've written this all in line. So if this seems like madness, if this is the first chunk of this coding you've seen, normally I'd pull all of these blocks out into separate functions, but I'm not really familiar with Vulkan at all. And I found pulling them all out into different functions made it hard to keep track of what was happening, because you had to keep jumping to different places to see things. Whereas I found this made it easy to just read like a book. You start at the top and you work down. It was much easier to navigate when I knew that there was a way to jump to a matching bracket. So let's have a quick look. Does Cocoon? I think all of their documentation's on GitHub. Let's take a little diversion and see if that's a thing that exists. Because if it isn't, that's kind of painful. What would it be? I guess it'd be in normal mode. The match. M to jump, select matching character, capital to extend the selection. So let's try it. If I hit M, beautiful. And then I guess the extending business is if I come here and I just hit M, you see it doesn't keep the last one. Whereas if I extend this up and I hit M, it does extend. So that's kind of cool. Okay, that's good to know. Everything we've been doing is inside of this init renderer function, except for our dinit, but that's quite a small chunk of logic. If we jump back to our main file, currently we have nothing actually in our main loop, which I think might mean the next thing to do is in here we're going to need a draw frame, right? So imagining, zooming ahead a little bit, we've got our pipeline working. Poll events is where we, I guess, flush the user events, which will be keystrokes and mouse movements. We'll then have imagine that there's a like an update game state step in here. Oops, game state. And then we want to draw the frame. So what on earth are we going to actually do in there? I guess maybe we literally just have a renderer draw frame function. Okay, so if we go back to renderer, oopsie daisy, renderer, we have our init, we have dinit, we'll also have draw frame, proc. Will you be able to mutate renderer? Possibly. I'm gonna let it. Screw it. What's the worst that could happen? Okay, so we've taken our renderer and I guess we need to allocate a command buffer. We need to record our draw command. And we need to submit our draw command. And then I assume there's a bit of thinking. Ugh, gross. Okay. Then I assume there's a bit of thinking to do in here about synchronization. So let's just pop a reminder there. And we'll call that back in our main.odin. In here, we'll just call draw frame with our renderer. Ooh, where have I put renderer? Init renderer. I put it on my global context. You return a renderer. I'm just not saving it. So let's do that. And then you can just take the reference to that renderer and do a draw. Just to check that I've not made an oopsie. We can come in here and we can say print line hello drawing. If we run that, we should see that just spams a million times. There you go. Cool. I can't lie, I'm kind of chomping at the bit to do this, but I also know that I'm going to get pulled away in about 15 minutes. And I really don't think that's going to be long enough for us to make meaningful progress on this. So I'll tell you what I might do is I will do a quick commit in here. So yeah, I'll say scaffolding draw frame. I'll push that up. And I might have a bit of a read, but I'm going to close that. I have no intention to do any more programming because, like I said, I think I'm about to get pulled away, and I think this will be a chunk. It'll be nice to get done in a go. I kind of thought the same about the graphics pipeline. I was a little bit bummed to not get through that in one sitting. So I might have to try and pick a chunk of time more carefully, see if I can get through a draw call. But reading can't hurt. So I will pull the sidebar up. Let me just look. That's a little bit small on the stream, so let me zoom it in slightly. I guess if you're in the stream and that's not readable, give me a shout. Command buffers. There's this notion of primary and secondary command buffers. I've seen this before, and I think basically secondary command buffers are called from primary command buffers. We won't need them for what we're doing, because what we're doing is very, very simple. Command pools we have seen. So this is what we would like to see. How to allocate command buffers. VK result. So it can fail because it's a memory allocation. Allocate info. Describing the parameters of the allocation. The command pool may be accessed at any time. Anytime one of the resulting command buffers is accessed. No, that's an interesting point. Again, so this is what I was saying. I'm not actually sure whether we're going to allocate a new command buffer on each draw frame, or if it makes sense to allocate them ahead of time, because what we're doing is the same every draw frame. But I'm going to assume we allocate a new one every draw frame, and if we can tidy that and pull it out later, we will. The allocate info, I think this is interesting to go and look at. And then, yeah, that's just an array of handles. Our allocate info takes the command pool that it will be allocated out of. Remembering the command pool has a what's the word? Queue family index, so it knows where on the GPU it's going to submit the work to. Level, I think, is a thing about kind of prioritizing work. So you can imagine a more complicated system where we're pushing lots of work around. You know, maybe as I move around the world, we're doing transfer commands to load in texture data for the next area that we're coming up to. That's lower priority than, say, the graphics call for the next frame. It's just a thing we need to have happen at some point in the near future, because in 5 seconds time you're going to need it. So I think that's what level exists for. Again, what we're doing is simple. No, I tell a lie. Okay, level means primary and secondary. Okay, that makes way more sense. That's simpler. Oh, I thought there was something about prioritizing different calls. Maybe it lives somewhere else. Reset command buffer. I don't think we're going to have to do this. Any primary command buffer that is in the recording or executable state becomes invalid. Bits which can be set on its flags we don't care about, because I don't think we're going to be doing it. And then you can free command buffers. Okay. Any primary command buffer that is in the recording or executable state. Okay, so it has the normal stuff for lifecycle management. Command buffer recording. You have to call vk begin command buffer with a begin info, which is a pointer to a struct that it probably tells us about down here. Yep. And it has a structure type, because everything does an extension pnext. It can have flags, and it can have inheritance info. Used if command buffer is a secondary command buffer, so we will not worry. Lots of stuff about valid usage. one-time submit, render pass continue bit, or a simultaneous use bit. This is probably useful to us. So one-time submit comes back to that kind of transient command pool idea, right? So that specifies that each recording of the command buffer will only be submitted once. The command buffer will be reset and recorded again between each submission. So that might be us. And what's this other one? Specifies a secondary command buffer is considered to be entirely inside of a render pass. Can be ignored. Fine. Usage simultaneous use specifies command buffer can be resubmitted to any queue of the same queue family while it is in the pending state and recorded to multiple primary command buffers. Okay. So again, what we're doing is simple. I don't think we're going to have to worry about this. So basically all we need to know is, are we setting this one-time bit or not? Which we probably will if we're going to allocate and record. We even have to allocate it each time, because I think it says you can reset. So maybe we actually do explicitly call reset at the end of each draw frame, and we make them all transient. If it is a secondary command buffer, it takes this inheritance info, which again gets squirrely. These don't exist anymore. In fact, none of these exist anymore. So, is there anything here about it being deprecated? It's not deprecated, but no. How relevant it is now that we're in dynamic rendering world, I don't know. If the VK command buffer will not be executed within a render pass instance, or if the render pass instance was begun with... Yeah, is that what it's saying? This is the dynamic rendering stuff. So yeah, it's saying what I'm saying. A bunch of those fields don't matter anymore. What is this? If a command buffer is in the invalid or executable state and the command buffer was allocated from a command pool with this, then a VK begin command buffer, and we did set this, didn't we? Oh, I've closed my code. I'm pretty sure we set this. Then begin command buffer implicitly resets the command buffer, behaving as if that had been called. After an implicit reset, it's moved to the recording state. Okay. So I think we might be able to create our command buffer once and reuse it over and over. And because we've set this, every time we begin command buffer, it's implicitly reset. Maybe we do want to write a bit of code there before I forget about that, because that's... Is it just me, or does that all feel kind of squirrely? Do I still have the tmux session open? I do. So let's grab that. So what do we have to say in there then? Is maybe we would rather allocate our command buffer way back. Where are we making our command pool again? Up here somewhere. Creates a vertex buffer, create command pool. So maybe the move is to say actually up here that we will allocate our command buffer. Can I do like that? And we can double check. So yeah, we've got this reset command buffer flag being set. Oops, sorry, that's all unreadable now. So we are setting this. Allocate a command buffer. See, I'm slightly confused only that when we allocate a command buffer, we have no idea how big that buffer needs to be. Or am I thinking about this too literally? If that's not clear what I'm saying, like when we allocate our vertex buffer, we have to say how much memory we need, right? We have to do all of this song and dance about getting the memory requirements somewhere there, so that we can do this memory requirements.size so that we can allocate out the correct amount of memory. I don't think I saw anything like that for command buffers. So what exactly that means, I don't really know. Okay, and then we're into all the extensions, so I don't know that we care about these too much. Did I just miss something in the allocation part? If we come back into here, or is it that it says something about the command buffer, or I guess maybe the command pool may be touched at any point. Where am I looking? Here. So we have an allocate info structure describing parameters of the allocation. Command pool may be accessed anytime one of the resulting command buffers is accessed. I assume what that's saying is allocations will just happen when they're needed. Because you, sir, have nothing about yeah, you have nothing in you about the size of the allocation. That's interesting. Okay, do you know what? Let's quickly add a command buffer. So we're in here. Oops, wrong button. So we'll come in here and we'll say command buffer, which over here will be a VK. What are you called? Command buffer. Its own distinct type. Cool. We jump back down or into here, and we're going to call VK allocate command buffers. We may end up making more than one. So I think if you follow the VK tutorial, they have this idea of having multiple frames in flight, which is about keeping the CPU busy while frames are being rendered. We're currently not doing that, but we may come back to do it, so that's good to know. We say in here we're going to have a result of VK allocate. Can't type. Allocate command buffers, which will take our renderer device. Again, if I could type renderer device, it will take an allocate info. That needs to actually be, oopsie daisy, a pointer to an allocate info. I have missed a button. So you look like that. Oopsie daisy. I find this actually really confusing. So if I'm here and I hit A, I would expect it to stay on the same line, but it actually drops a line. So if I'm here, I actually want to hit I to stay on the same line. Weird. And then I've pointed to command buffers. We're only allocating the one, so we can do it directly to command buffer. So we can just do that. If res not equal to success, we say we say delete panic, failed to allocate command buffer. It's not the fanciest error handling in the world, but it works. Then we need to make our allocate info, which will be a VK command buffer allocate info. And then we need to jump down to see what you have in you. And what you have in you is our old favorite S-type command buffer allocate info. You are missing a dot. Did it again. We're in here, we come to there. Pnext we don't need, I don't think. We can pass in our command pool is our renderer command pool. Our level is a primary. And command buffer count. Oopsie daisy. Come back, change, command buffer count is 1. So we bump that up like this, and then I guess in our dinit function, so we're all the way back down here, we need to free our, what's it? I'm kind of curious actually if that complains, because I thought one of the points of having these pools is that they manage the memory for these things for you. So why do I need to free the command buffer? What am I running? Odin run main. Close it. Yeah, it doesn't complain, does it? Okay, I'm going to leave it then. I'm guessing when you destroy the command pool, that must free the associated memory. So back to our command buffer. Sorry, command buffer. Didn't get it. Maybe I'll try it. This one other thing. So I guess while we got a spare minute just before I finish, I am playing around with Cocoon. If you've not seen these before, normally I'm in Neovim. I'm a big Neovim fan, used it for years. But one of the things that dragged me into trying Cocoon out is I quite like the idea that they have where they're like, we implement basically nothing and we encourage easy, I guess like shell script and shell tool integration. So I've written a little dumb thing so I can go grep for something. So I can come in here and I can do like renderer dot command buffer, and this will dump out into a scratch buffer that it doesn't expect you to ever write. And then it keeps it so I can jump back and forward. And this took like 3 lines of like bash essentially, which I thought was cool. I'm not going to say it's particularly convenient, but I had a good time with it. It was fun enough that it's got me tempted to keep playing with it a bit more. So I can see that that's back on line 277. So I can now jump to here and I can go to 277. And what was I going to do up here? I allocate the command buffer. I can't remember what I was going to do. I sidetracked myself. Yeah, I actually can't remember. I was going to have a quick look for when we destroy a command pool, if there was anything in here about what it does to the command buffers. So we have destroy command pool. All command buffers allocated from the pool are freed. Yeah. Thought so. So yeah, we don't have to worry about tidying up our command buffer on its own. Nice. Okay, so we have a command buffer available. Next time around, we can pick up from there. I guess that will put us into here. I would like to take this out, if I'm honest. I would like to say in here, to do next is use the command buffer we've just allocated. To submit to record draw commands. Cool. Yeah, like I said, I'm afraid I think I'm gonna have to run away. But we've now got it running. We've got slightly further, so we've got a graphics pipeline made. Fingers crossed is configured correctly. We've got a command pool. We're ready to start doing draw commands. We haven't thought about synchronizing yet. That may come up next time. That may come up in the future. But progress nonetheless. Thank you for joining me. I hope you found this interesting. And yeah, I'll see you in the next one.